Hello, I'm Brian Byrne, EMVCo Director of Operations. As part of our series exploring key EMVCo initiatives, welcome to this webcast on EMV 3D Secure 2.0, or 3DS 2.0. In 2015, EMVCo announced that it would lead the payment industry in advancing 3DS. With the release of EMV 3D Secure Protocol and Core Function Specification version 2.0, EMVCo aims to support the payments industry in delivering a globally interoperable and consistent 3DS user experience across all e-commerce channels and connected devices. This will promote consumer familiarity, convenience, and security. In this webcast, Craig Gilbert, Chair of EMVCo's 3DS 2.0 Task Force, provides an overview of EMV 3DS 2.0 and shares the drivers for a new specification. Listeners will also receive insight into some use case examples. I will now pass you over to Craig.
Thank you, Brian, for the introduction, and welcome to those of you who are listening into this webcast to get some background information on EMV 3DS 2.0. We're going to be taking a look today at the full construct of 3DS 2.0, and as part of that journey, we begin at the origin of where EMVCo started to look at 3DS 2.0. And when we started to look at it, we noticed that there were some areas where we wanted to expand and improve on the current foundation. But overall, 3DS and the premise is where we're building from. So we've got three, and the 3DS stands for the three domains. So three domain secure, and the three domains are kept and brought forward into 3DS 2.0. So we have the merchant and acquirer domain, the interoperability domain, and then we have the issuer domain. As we go forward through this presentation, you'll see how each of those parties, those areas, are structured in the flows and what that means. But this base construct is what builds our initial building block or a foundation of EMV 3DS 2.0. One of the key questions that you might be asking yourself, and we've heard others ask, is why is a new version of 3DS required? We were looking at the marketplace today, and we recognize that there is a big trend towards mobile devices, usage of mobile devices, the Internet of Things, and connectivity. And we realized that the current version of 3DS didn't really support the use natively of those different devices and channels. So one of our initial goals was figuring out how we could build a specification, so 3DS 2.0, how we could craft it and design it to support app-based purchases. So this would cover all connected device purchases. So whether it's your mobile phone, it's a gaming system in your home, it's your car, any type of device or environment that supports an app or supports a browser would be able to take advantage of our 3DS 2.0 specification. Another key area was looking at how we could take the 3DS 2.0 specification and better integrate it into a merchant offering. We wanted to ensure that there was a smooth checkout process so that the challenge response flow didn't necessarily interrupt the merchant checkout experience and pull the consumer away and potentially create abandonment. So that was a focal point of how can we do this, how can we design this to potentially even allow for what will be referred to later as a frictionless flow. And finally, we wanted to facilitate a cleaner experience without sacrificing security. Without the security, the EMV 3DS 2.0 specification wouldn't have a lot of value. So the security of the specification and the flows is a foundational element. We need to make sure that the payload and the information is protected. And one of the things that we looked at was how can we do that while still protecting and making the flows as clean and easy as possible. So the first bullet that you see underneath the clean experience is encouraging frictionless authentication, which I talked about a second ago, which is really facilitated by a richer exchange of data and information on the consumer's device and the information that they're about the product that they're purchasing, so that the issuer or access control server has the ability to authenticate the consumer without even requiring a step-up or a challenge. And then we've also looked at better use of one-time passcodes to enable authentication without a lot of back and forth and really making sure that it's a nice, secure process. So before we go further, we do want to highlight the role of EMVCo in EMVCo 3DS, or in EMV 3DS 2.0 in terms of the specification. So this slide highlights what EMVCo does and what EMVCo does not do. And I'm going to focus on what EMVCo does around 3DS 2.0. So specifically, we develop specifications that support secure e-commerce transactions in a globally interoperable manner. We enhance those specifications based on industry feedback. We also maintain vendor and service provider relationships. We collaborate with other industry bodies. We implement and manage a testing and approval program. And finally, we deliver a royalty-free specification toolbox to be adapted by global, regional, and domestic payment systems in order to meet regional market variations. So this slide right here highlights some of the use cases that we've been able to look at and structure 3DS 2.0 around. The left-hand side of the screen highlights the payment authentication flow. That is currently present in the 3DS that's in use in the market today. And we've taken it, and as highlighted previously, EMVCo has focused on making it function in an app-based mode and focused on enhancing and improving the authentication experience. So you've got the ability for a mobile payment application to take and process it. It can be a frictionless authentication, or it can be a challenge response. And those challenge response flows have been designed to make it as convenient as possible for the consumer. We've tried to do what we could to make sure that the browser flows match as much as possible to the app-based flows. And so you'll see that we also have a frictionless flow and a challenge response flow for both the app-based and the browser-based scenarios. While we were working on 3DS 2.0, we did recognize that there was a use case or a whole new opportunity to take the overall security structure and the flows and utilize it for a new purpose. And that's the area of non-payment authentication. So an example that we looked at to help kind of paint this picture is utilization of EMV 3DS 2.0 and the flows to allow for cardholder verification to support an activity such as adding a payment card to a digital wallet. And this would be a scenario where you're not making a payment, you're not purchasing something, hence non-payment, but you're still wishing to authenticate that you are who you say you are with your issuer in order to be able to add that card into the wallet. So the following slide highlights the base constructs within the 3DS 2.0 specification. So as I highlighted previously, we began and focused around payment authentication. That is the framework and the building block that we utilized to build up 3DS 2.0. So you see on the left-hand side, we've got our focus on our app-based flows. On the right-hand side, we have our browser-based flows. And our intent as we built the overall framework and as we looked at 3DS 2.0 was to ensure that both sides, the browser and the app, flowed as close to each other as possible. So really we aimed, and we use the phrase here, symmetrical. We tried to make those two things be as similar as possible for both the user experience and also the way that the transactions were processed. Again, we began with a building block of the application-based flows. We looked at the flows, created the flows, looked at the security around it, looked at the user experience, and once we had created that foundational layer, starting with the app-based and then moving to browser, we then looked and turned our attention towards the non-payment authentication flows, which is what we just spoke about previously on the slide that came before this. And then we took and figured out the data elements, any nuances of the flows, any specific changes we would have to make in order to support that, and we were able to construct that non-payment authentication flow. And then finally, we looked at our digital wallet layer, if you want to highlight it as that, and figured out how that digital wallet really leveraged the previous two layers. So the digital wallet layer is figuring out how we can allow for any specific wallet to integrate into a 3DS 2.0 flow and allow for a non-payment authentication, which we highlighted before, which would be, the example would be adding a card into a wallet, and then the payment flow, which would be utilizing that card that's located in that wallet. So we built from that foundation and gone rung by rung or layer by layer to create the specification to support these core constructs. As we go along, we're going to get into a few slides that are going to demonstrate the specific flows, and this slide here illustrates the actors, and wanted to just make sure that the audience was aware of the particular actors or the components in a typical 3DS 2.0 flow. So in the top left, and I'm going to use the laser pointer for this, the top left, we've got the SDK. And the SDK, it runs on that app, so it runs on the device within the app that's engaging a 3DS 2.0 flow, and it communicates with the 3DS requester environment and the ACS. And this is a key element in order to create that 3DS 2.0 flow in the app-based world. The 3DS method it's almost the counterpart to the SDK. So in a browser-based world, the 3DS method allows for the browser to obtain additional information. The flow grabs the information from the 3DS method, and it helps to facilitate that risk-based decision that we talked about before, so we can achieve that frictionless flow. The 3DS server is the server that gets in the requester environment and gets the information, and it's the actual full initiation point of any 3DS 2.0 flow, and it connects in and communicates directly with the directory server, which is inside that interoperability layer. The directory server is operated by varying payment systems and stands in the interoperability layer and helps to direct the communication towards the appropriate access control servers for the authentication of the various transactions. And then finally, the access control server is the party that receives the information on the either payment or non-payment authentication message and makes the determination of the authentication, whether it's a frictionless or a challenge response. The ACS is accountable for making that decision. So now what we're going to do is we're going to kind of give you a high-level view of what a 3DS 2.0 flow looks like. First, we'll take a look at it from the consumer experience side, and then after we take a look at it from the consumer experience side, I'll show you what the flow looks like as it's envisioned with the various components to kind of highlight how the flow actually functions. So in this scenario, you have to imagine that I'm trying to buy an item at within an app on my device at a particular merchant. And in this scenario, I'm adding the item to my shopping cart, and when I'm ready, I'm going to click Checkout. When I hit the Checkout button, I've confirmed my purchase, and that initiates the 3DS 2.0 flow. So as you can see up in this second box, at that point in time, once I've hit confirm, the flow initiates, the purchase information and device data and other details are submitted to the ACS in order for the ACS to determine and authenticate the consumer. So over here, we see that the transaction is processing, and then the consumer finally, over in this far right side, sees that the transaction was successful, and what's happened is all the information has been conveyed over to the ACS. The ACS was able to look at the details and validate that they had enough information to feel confident in the purchase and authenticate the consumer. All of this happened, the consumer was protected, and there is no interaction, so there is no friction, and that's why we call this a frictionless flow. There is no friction, there is no need for the consumer to step up or to enter any type of password. They can handle this all just by the standard flow, just by having their merchant connected into a 3DS 2.0 flow. This slide shows what we just witnessed from the consumer side. This actually will help you to see the way the actual flow functions using the various components. So 2 slides back, we saw the varying actors, and I'll help to try to walk through the flow so you can see how the function actually is processed. So as a consumer is in the application on their device, they're checking out, and then we've got our, as we highlighted before, we have our SDK. So this is our 3DS client. Our SDK is here, and I'll highlight that up in this box, we've got this 3DS requester environment. This works for both a payment and non-payment authentication flow, but we'll highlight this time that we're looking at a payment flow, payment authentication. This blue box with dashed lines around it has been constructed, and the dashed lines indicate that there is a message that's occurring, but it's not specified. So it's not called out within the specification. We do require information to be delivered to this 3DS server, and the 3DS server initiates the flow. You can see the solid lines. The solid lines are the messages that are specified in the 3DS 2.0 specification. But one of the things that is intentional and was a design choice from the 3DS task force was to make sure that this requester environment allowed the right level of flexibility to reflect the merchant space, where we've got varying scenarios. We have different dynamics where we have a merchant that might be their own large-scale merchant. There might be payment service providers, regional variances. So this scenario allows for all types of parties to connect. The specification highlights a couple of key features, and those are the features that need to be considered and maintained, but there's plenty of flexibility to allow for the parties in the merchant space to build their component and adhere to the specification. So again, let's go back to the flow. I'm here, I'm buying something, my SDK pulls my device information, the information about what I'm purchasing, and any relevant details are passed across over here. Again, we're not specifying how. As it arrives to the 3DS server takes all that information that we just described, the device information, the purchase information, and it takes it and sends an authentication request over to the directory server. The directory server, in turn, processes it and determines which access control server the message needs to go to for verification and authentication. In our scenario, it's sent across as an authentication request over to this access control server. The access control server receives all the information, determines that the authentication should take place, they're okay with it, and sends back an authentication response back again through the directory server, which is then conveyed all the way back to the 3DS server to close the loop. Now, that is our authentication flow. For sake of completeness, we do highlight another dashed line that shows what would happen. So to complete the actual full purchase or the authorization, the information is then sent back through the acquirer, an authorization message is sent over the payment network, and finally, sorry, the transaction is completed. So now let's take a look at a scenario where the frictionless flow isn't enough. It's not sufficient. So this is a scenario and one of the challenge responses. There are several. We've created within the specification a number of different scenarios to allow for flexibility for the challenge response. This one in particular is a one-time passcode flow. So very similar to the previous scenario, I'm inside an app, a merchant app on my device looking to make a purchase. I go ahead and I add things to my cart. I hit checkout. Again, that's where the 3DS transaction initiates, and the information is taken and, as we saw before, conveyed across to the 3DS server and then through to the directory server and all the way over to the ACS in order to determine whether or not they can authenticate. In this scenario, as the information is passed across, the ACS determines that they don't feel, with the information they have, confident enough to allow for an authentication to occur in a frictionless manner. So they're going to challenge me, the consumer, to provide information. And in this scenario, what's happening is, and you can see it here, a new screen appears, so a new window appears, and it's asking me to input a one-time code that's been delivered to me into this. And the 3DS 2.0 specification highlights that there's a one-time passcode scenario, and it highlights that you are to use a one-time passcode. It does provide flexibility. So we could assume, for instance, in this scenario, a one-time passcode is delivered via a secure application on my device, and I'm seeing the notification and then typing in a one-time passcode here. And once I type in that passcode, what happens then is the ACS control, the access control server, the ACS, is going to validate whether or not that value is the correct value or not. If it does validate that the value, the one-time passcode, is the correct one, it will go ahead and authenticate me. If not, it may or may not ask me to do it, repeat it again. That's going to be left up to the varying parties. But this general flow is how a challenge response step-up type of scenario would function. So we saw the consumer experience, and what I'm going to do now is just highlight the nuance, the difference in the actual challenge response flow for the different components. So we saw in the initial flow with frictionless flow, and this is something to highlight, every 3DS 2.0 flow goes through and has an authentication request, authentication response. That's our first building block. That's the first flow. It happens every time. So every transaction has a potential of being a frictionless flow. It may not be, based on the ACS and based on potentially regional requirements and restrictions. So the transaction flows, as we looked at first in the previous example, it flows across all the information, device information, the purchase information comes across, it comes over to the DS, and then over to the ACS in the form of the authentication request, comes back in the response. But in this response, the ACS is saying, no, we cannot authenticate, we need to challenge. And what's happening in this scenario is it's passing along information to the 3DS server, which is conveyed excuse me, back to the 3DS client, and that basically provides the 3DS client with the information to create a secure channel and create this challenge request response between the 3DS client and the access control server. That's the scenario that we showed, and that was the window where we saw the one-time passcode, and I was able to enter my one-time passcode. So this creates that secure channel between that client and the ACS that allows for me to enter my data, allows for the ACS to validate, and upon either success or failure, the results response information is sent from the ACS back to the directory server, and the directory server then takes that and sends it back to the appropriate 3DS server so that the transaction can be finalized. So then again, that's the last leg of the actual specification. If it were a successful transaction, then you could see it flow down through to the acquirer, an authorization message, and then over to the payment network and over to the issuer as the transaction is completed. So the browser world, as we talked about before, is very similar, and we tried on purpose to make it as similar as possible so that a consumer, when they're authenticating in the app-based scenario, if they would switch to a browser, they would see a very similar experience. What we're seeing on screen here is a browser flow with a light box. So here's the light box on top of the merchant page in the background. And very similar scenario, let's assume that a frictionless authentication was attempted. And here we're asking the consumer to enter in a passcode. So this shows how there's a very similar flow for both. They look very similar. This helps with the overall authentication process and awareness from the consumer side. The flow looks very similar. This is just highlighting the frictionless flow. Didn't go into the challenge response, but we're highlighting the frictionless flow for a browser. And you can see the real difference, and it's really hard at this stage, but the real difference would be this would be a browser as opposed to an SDK and an app. So this would be the browser flow, and we have our 3DS method here, and the transaction would flow this way over across, and the 3DS server would be able to gather the details on the transaction and various device information, browser information in this case, and pass that along through the authentication request, response, and then back up. So it's very, well, it's not even, I wouldn't say very similar, that's probably not strong enough. It's identical. The only real difference in the flow is that this one initiates from a browser, whereas the app-based initiates from an app with an SDK in it. Within EMVCo and within the 3DS task force, the group that was working on the EMV 3DS 2.0 specification, we recognized that there were other groups within EMVCo that were doing innovative things in the payment space, and we wanted to be aware of those and try to collaborate and consider areas where we could look for the synergies. So in particular, I highlighted this earlier, as we were building out the payment authentication flows, and I'll kind of highlight over here, we were looking at the fact that the payment authentication flow had a lot of the same parties. So we have our acquirer, we have our interoperability domain, and our ACS or issuer domain. And we said there's an amazing amount of overlap in those parties. And is there any way that we can leverage the EMV 3DS 2.0 messages to handle payment and non-payment? And that's where we started kind of that conceptual approach. And as we put that out there, we were collaborating with the tokenization working group within EMVCo and speaking about some of these concepts. And we came up with an objective to identify key areas of overlap where we could take the 3DS 2.0 specification and what the tokenization working group have been working on and look at creating something that was beneficial for the overall payments industry. So we were able to come up with 2 use cases that were at this stage highlighted as under evaluation, but I would say more than that, we actually took and constructed 2 use cases that are woven into the fabric of 3DS 2.0. So the first one is utilizing 3DS 2.0 to allow for a non-payment authentication flow, and we believe that that is a scenario that non-payment authentication flow could be utilized within a token flow. And then the other area was looking at the fact that payment tokens, in particular the EMV payment tokens, are becoming more and more prevalent, and we wanted to make sure that a 3DS 2.0 flow could work regardless of if it was a an actual physical credit card number that was being utilized, the payment card, or it was a token, a payment token. And so we were able to take a look at that and ensure that the 3DS 2.0 flows accounted for the possibility that there could be an actual account number or a token within our flow. So that wraps up my presentation. Hopefully it was informative. If you do want to learn a little bit more on 3DS 2.0, we will have the specification out on the website. We'll also have a FAQ document and a full landing page with other material for you to read. Thank you very much. Brian, I'll turn it back to you.
Thank you, Craig. If listeners have any further questions, please contact us via the EMVCo website.